The universe appears vast, chaotic, and unpredictable, yet hidden beneath this cosmic complexity are powerful forces that shape everything. From the motion of galaxies to the formation of atoms, these invisible influences govern reality itself. Scientists have spent centuries trying to understand them, but many mysteries remain. Some forces are well known, while others are still poorly understood. Together they form the hidden framework that controls how the universe evolves, expands, and ultimately determines the fate of all matter and energy. The first and most familiar force is gravity. It is the force that pulls planets into orbit, shapes galaxies, and binds the universe together on the largest scales. Though gravity is the weakest of the fundamental forces, its influence stretches across enormous distances. Massive objects bend spacetime itself, creating the gravitational fields that control cosmic motion. Without gravity, stars would never form, galaxies would never assemble, and the universe would be nothing more than scattered particles drifting endlessly apart. Another powerful force is electromagnetism. This force governs electricity, magnetism, and light. It is responsible for the behavior of atoms, molecules, and chemical reactions. Every spark, every beam of light, and every technological device relies on electromagnetic interactions. In space, electromagnetism drives powerful cosmic phenomena such as solar flares, pulsar emissions, and energetic jets from black holes, making it one of the most visible forces shaping the observable universe. Deep inside atomic nuclei, an even stronger force exists: the strong nuclear force. This force binds protons and neutrons together inside the nucleus of an atom. Without it, the positive charges of protons would repel each other and atoms would fall apart instantly. The strong force is incredibly powerful, but it operates only over extremely tiny distances. Despite its short range, it is responsible for the stability of matter and the existence of the elements that make up everything in the cosmos. Opposing the strong force is another subtle but important interaction, known as the weak nuclear force. This force governs certain forms of radioactive decay and plays a critical role in nuclear reactions inside stars. It helps control how particles transform into other particles, allowing processes that generate energy in stellar cores. Without the weak force, stars would not burn in the way they do, and the chemical evolution of the universe would be drastically different. Beyond these four fundamental forces lies something far more mysterious: dark energy. Discovered in the late 20th century, dark energy appears to drive the accelerating expansion of the universe. Instead of gravity slowing cosmic expansion, space itself is stretching faster over time. Dark energy seems to act as a kind of repulsive force embedded within spacetime. Yet scientists still do not know what it truly is or why it exists. Closely related to this mystery is dark matter. Unlike normal matter, dark matter does not emit, absorb, or reflect light, making it invisible to telescopes. Yet its gravitational influence is unmistakable. Galaxies rotate faster than they should based on visible matter alone, suggesting an unseen mass surrounding them. Dark matter appears to form massive halos that shape the structure of galaxies and clusters across the universe. One of the most fascinating aspects of these mysterious forces is how they interact with spacetime itself. According to the theory of relativity developed by Albert Einstein, gravity is not simply a force, but a curvature of spacetime caused by mass and energy. Massive objects distort the fabric of the universe, causing other objects to move along curved paths. This insight transformed our understanding of gravity forever. At the smallest scales, quantum mechanics reveals a different picture of reality. Instead of smooth and predictable motion, particles behave like waves of probability. Forces emerge from the exchange of tiny particles known as force carriers. Photons carry electromagnetic force, while other particles transmit the nuclear forces. This quantum framework describes interactions at the smallest scales with extraordinary precision. Despite decades of research, scientists still struggle to unify gravity with quantum mechanics. The two theories describe reality in very different ways. Gravity dominates at cosmic scales, while quantum physics governs the microscopic world. Finding a single theory that explains both remains one of the greatest challenges in modern physics. Such a discovery could reveal entirely new forces or hidden dimensions of space. Some theoretical models suggest that additional forces may exist beyond the four known fundamental forces. These hypothetical interactions could operate at extremely small distances or under extreme energies that current experiments cannot yet reach. If such forces exist, they might explain mysteries like dark matter, cosmic inflation, or the structure of space-time itself. Another mysterious influence shaping the universe is cosmic inflation. This theory proposes that the universe expanded incredibly rapidly during the first fraction of a second after the Big Bang. A powerful unknown field may have driven this explosive growth, stretching space-time faster than light. Inflation explains why the universe appears so uniform and smooth across vast distances. Magnetic fields also play an important but often overlooked role in the cosmos. They influence the motion of charged particles, shape stellar winds, and guide the formation of cosmic jets. Magnetic forces can extend across enormous distances in galaxies, affecting the behavior of plasma and radiation throughout interstellar space. Gravitational waves represent another subtle but powerful phenomenon. When massive objects like black holes or neutron stars collide, they send ripples through spacetime itself. These waves travel across the universe at the speed of light, carrying information about violent cosmic events. Their discovery opened an entirely new way of observing the universe. Despite our growing knowledge, the true nature of many cosmic forces remains unknown. Dark matter, dark energy, and the origins of fundamental interactions are still unsolved puzzles. Each new observation reveals deeper layers of complexity, reminding us that the universe is governed by mechanisms far stranger than we once imagined. The forces controlling the universe are both powerful and mysterious. They shape the birth of stars, the motion of galaxies, and the structure of spacetime itself. Yet humanity has only begun to understand them. Somewhere in the depths of cosmic physics may lie new forces and hidden principles that could transform our understanding of reality and reveal how the universe truly works.